All right, hello everyone, and welcome back. Today we're going to be talking about segment addition postulates. So that is what we are going to be doing today. By the end of this lesson, you'll be able to answer these two questions here. Why is the first step in constructing a copy of a line segment? We don't need that. That's a joke. Let's delete. Hello everyone, and welcome back. Today we're going to be talking about segment addition postulates. The question that you're going to be able to answer by the end of this lesson is, how do you write an equation based on these segment addition postulates? So the first thing that we need to get into is actually how to set these up, what it actually means. So let's go ahead and jump into it. Make sure that you have your notebook here next to you. Don't forget to type the essential question into the notebook. And there's also some additional resources for you to use. We're going to go over these examples here. And then I'll also complete a problem that is similar to number 4 down here. It's not going to be number 4, but it's going to be one that's similar. And by the time that we finish, you should be good to go to do this all on your own. So, segment addition postulate, here it is. Basically what we're doing is we are taking two different segments and we are adding them together to make a larger segment. So the two segments that I have here that I'm adding together are A and B. And then I go from B to C, and that makes my second segment. So I have AB plus BC, and then that gives me AC. So that's where this formula is coming from. I can do this with any 3 collinear points. You can do this with any 3 collinear points. And it doesn't matter if these are rearranged in any order. Whichever point is in between the other two, you're just going to go from one endpoint to the point that is in between, and then the same point that's in between to the other endpoint. Notice I said in between. Just because B is between A and C right here does not mean that B is in the middle. So let's go ahead and take a look at a few examples here. This first example, we're going to find segment TU. So I'm going to take the same formula that we had on the previous slide, and I'll write that up here. But I'm going to rewrite it in terms of the letters that we have up on the screen. So TU plus UV is equal to this entire length here, this entire segment, TB. So when I add the two small ones together, it gives me the large one. Now the second thing that I'm going to do is I'm going to plug in what I know for each segment. So I know that segment TU is this question mark here. So there's two different ways that you could do it. You could either put a question mark, or you could use a variable. It's just a placeholder. It's a letter, and that's the most common notation. So we use X most of the time, and then I come over here. I'm going to plug in what I know for UV, which is 20, and then I set that equal to the entire length, which is 32. And now from this point, what I'm doing is I'm solving for X. My goal is to figure out what X is because X represents TU. So I need to get rid of the 20 on both sides because we don't need it there anymore. So I subtract 20. I'm basically just doing the opposite operation here, right? So we have a positive 20. I need to get rid of it, so I do the opposite of addition, which is subtraction. And then what that does for us is it cancels these two out. And then everything else is just a regular operation. So I bring the x down. X is now equal to 32 minus 20, which is 12. Now you're saying, oh, x is equal to 12. Yes, that is correct. This is not your answer though, because remember, we're solving for TU. So I'm going to replace x with TU, and that is equal to 12. I circle my answer. So there's one example. We can do the same thing with HJ, right? Except this time, HJ is kind of in this weird place. So what I'm going to do is I'm going to make this figure, because that's what represents HJ. And I have to use some context clues to figure out the other missing pieces, right? So I have this little piece right in here from H to I that I don't know anything about because nobody told me anything about it. So I'm going to use some of these things, some of the other numbers that they provided for us to figure out what HI is. Okay, so I know that from G to H, that distance is 2. So GH is 2. And then if I add HI, I get this 7. So G all the way to I is a total length of 7. And I plug in what I know. I've got the 2 for GH. I know that GI is 7. It means that we're going to call HI X. 2 plus X equals 7. This X is 5. Right? So this is not our answer because we still have not found what HJ is. Okay, but we needed HI because to go from H all the way to J, we have to know what this distance is. So again, that was the whole reason that we found HI. So this 5 just gets placed right here. And now for HJ, HJ is equal to HI plus IJ. And I now know these two links. So HJ is equal to 5 plus 12. And that is a total of 17. So sometimes with these problems, they're not going to give you an easy way to get out of it. You're going to have to use some context clues and think a little bit to solve the questions. Right, so now I'm going to pause the video. I'm going to let you work on EC, and then once you've completed EC, you can go ahead and resume the video, and I will have the work written out for you. All right, so here's the work. We'll go over these step by step, just talk about them. So the first thing that we need to do is we need to figure out some kind of formula to use with EC. So we know that EC goes from here to here. Okay, and then all the points that, or all the segments that make this up are E to D, and then D to C. So E to D is all of this, which we don't know, but we do know from D to C, so that's 16. So step one is just writing down this formula EC is equal to ED plus DC. And then step 2, all we did was we just substituted what we knew into this formula. Now, since we don't know what ED is, we have to figure that out. So over here on this side, we have step 3. So to figure out what ED is, there's a couple things that we can do. The easiest, I wouldn't say the easiest, but the way that I thought about it was I'm going to take the entire segment from E to B, which is 49. I'm going to take this entire segment, and then I'm going to take away everything that is not ED. So again, I'm going to take this entire segment from E all the way to B, and that's the 49. And then I want to take away everything that is not ED. So when I do that, I'm basically just subtracting D to B. And they gave us that length right here, it's 30. So once I subtract it away, I get that ED is 19. And now I can take the 19 and come back to my formula and plug it back in. So our step 4 is plugging our 19 back in. 19 plus 16 gives us 35, which is E to C. So that one's a little bit more complicated. Just like how we can add segments together, we can also subtract segments as well. And that's what we used right here. So this would be a little bit of segment subtraction. Now for this last question here, this last box, we're saying that points A, B, and C are collinear, and that point B is between A and C. So for this question, anytime that we have a word problem, the best thing to do is always to draw a picture. So I'm going to make 3 points, and I have A, I have B somewhere. We'll just say that B's here. And then over here I've got C. And then there's a line that connects them all together. So again, the reason that the picture looks like this is because they told us that point B is between point A and point C. So they want us to figure out what AC is. So I'm going to do AC right here in green. They want us to figure out what this is. So I'm just going to call it X. X again is just a placeholder. And then I'm going to take what I know, which is AB is 16 and BC is 12. And I plug them into their respective places. And we know that when we add 2 small segments together, we get the larger segment. So AB plus BC is equal to AC. Then I just plug my numbers in, which is 16 plus 12. I'm not going to replace X. There's no need to. 16 plus 12, 28. So here's some things that you need to think about. In order to apply the segment addition postulate, what pieces of information must you already know? What must you already know? Think about those things. We just talked about them back here on this slide. So what information must you know to use the segment addition postulate? Now equations and segments, that's what this problem right here is for. Nothing changes with the way that we go about solving the problem. So when I say that, they want us to find DE. So they want us to figure out what 3x minus 28 is. Nothing changes in terms of how we add the segments together. So going from D to G, I know that I can add all the small pieces together and the total length is going to be 33. So the way that this would look in terms of the points would be DE plus EF plus FG is equal to DG. So we have DE right here, and then we add in EF, which is a small piece, and then we add in FG, which looks a little bit bigger than the EF piece. So now I just plug in what I know. So I've got 3x minus 28 plus 3x minus 30 plus 1x is equal to 33. Now from this point, it's all about combining like terms and manipulating this equation to get x by itself on one side and then a number on the other side. So when I combine all of these things together, whoops, keep that blue. I meant to click the draw button. So when I combine all the x's together, I'm just going to circle all the x's in yellow. So I have 3x, another 3x, and then just 1x by itself. So what we have is 3 plus 1, and that gives us, I'll go back to the text box real quick. It gives us 7x. I don't like that. 7x. There, sorry about that. Okay, and then the other thing that I'm going to combine together is this 28, and it's a negative 28. It has a negative sign in front of it, and this negative 30. So negative 28 plus negative 30, this ends up giving me negative 58. So I have 7x minus 58 equals 33. Now I got to get rid of the 58, so I add 58 to both sides. Then we end up with 7x. These cancel out. And this is going to be a 1 and a 9, so 91. Now the 7 and the x are being multiplied together, so the opposite of multiplication is division. So I'm going to divide by 7 on both sides. And then that gives me a total of 13. Okay, now this is not the answer, because this solved for x. Okay, I can't repeat this enough. You will see this so many times. Just because you get x equals a number does not mean that it's the answer. This is not the answer. Because remember, our goal was to figure out what DE is. DE is 3x minus 28. So I have to take this x and plug it back in here. So what I'm really doing is I'm doing 3 times 13 minus 28. And that's going to give me DE. So 3 times 13 is 39 minus 28. Gives me 11. So we got a lot going on with these segment additions, but once you get the hang of it, it's really quite simple. This is one of the reasons why we did the algebra review at the beginning of the year, because we're going to be using algebra throughout this entire course. So that's just a little bit of the algebra that's going on. I'll post this PowerPoint into Google Classroom, and there's There's a video over some practice problems, as well as extra practice in Khan Academy and Quizlet. Don't forget to make sure that you fill in your notes, and you also have some extra examples here. Lots of resources for you to use. If you have any questions, please post them in Google Classroom or shoot me an email.